Today you'll be doing lesson 5.5, graphing inequalities. At the end of this lesson, you will be able to graph inequalities in slope-intercept form and determine if points are solutions or not. In order to graph an inequality, you need to know what the symbols mean. The greater than symbol means to shade above. So you'll be shading above the line you draw. That means it's going to be a dashed line. A dashed line is like an open circle. It does not include the solutions that lie on it. The less than symbol means to shade below. So you're going to shade below the line you draw, and it is also dashed to show that the points it passes through are not included, just like the open circle. Greater than or equal to means to shade above, and that's going to be a solid line, meaning it includes every single point on the line, just like the filled-in circle from 5.3. Less than or equal to means to shade below, and that is also a solid line because it includes all the solutions that are on that line. Shading above means shading on top of the line you draw. Shading below means shading below the line you draw. In order to graph the line, you need to have it in y equals mx plus b. So the first thing is to plot the y-intercept, which is your b. It's a coordinate 0, b. And then plot the remaining slopes points with the slope using rise over run. Rise is the change in y over the change in x. If a line is in the form x equals a number, then it is a vertical line. Remember, that's where you have an undefined slope, because every single x value repeats. It is a line drawn through an x equals number. But you still need to look to see if it's a solid or dotted line, and then shade left if it's less than or equal to, and shades to the right if it's greater than or equal to. These arrows point to the left, so you shade left. These arrows point to the right, so you shade to the right. Alright, so example 1. Y is less than 3x minus 5. It's in slope-intercept form, so I don't have to change anything. I know I need to start at the y-intercept, which is 0, negative 5. That sign tells me it's negative, the subtraction sign. So I plot that point, 1, 2, 3, 4, 5. Then I have to look at my slope. I have a slope of 3 over 1, which means I have a rise of 3 and a run of 1. So to plot the next point, I'm going to rise 3, 1, 2, 3, and run 1. Rise 3, 1, 2, 3, run 1. I need to decide if I have a solid or dashed line. It is a less than symbol, which means it's going to be a dashed line or a dotted line, so that it does not include the points that I've graphed. So I'm going to graph my line now as a dashed line. And put my arrows on the edge because it does go on forever in both directions. And the way I always determine if it's above or below is by checking a point. We can check the point 0, 0. If I plug 0, 0 into the equation, 0 less than 3 times 0 minus 5 means that 0 is less than negative 5 because 3 times 0 is 0, so on left is negative 5. Is 0 less than negative 5? No, it's not. 0 is a number that's greater than negative 5. So this point does not make it true, so then I want to shade below. So I shade away from the 0, 0. Anytime the point 0, 0 is not true, shade away from that point or on the opposite side of the line. So there's the inequality, y is less than 3x minus 5. All the solutions are my red. Every single point in red. Now we need to check and see, is 3, 2 in the solution set? The easy way to do it is to graph 3, 2. 1, 2, 3, 1, 2. And that lies in my red area, my shaded area. So I would put yes. The other way to test it is to plug the point into the inequality. 2 is y, 3 is x. So the 2 is going to have to be less than 3 times 3 minus 5. 3 times 3 is 9 minus 5. 9 minus 5 is 4. Is 2 less than 4? Yes, it is. So I proved it algebraically, and I have the proof on the graph showing that my green dot, the point 3, 2, is in the shaded section. Example 2, y is greater than or equal to negative 3/4 x plus 2. I know I need to start at my y-intercept plus 2, so 0, positive 2. So there's my starting point. I have a slope of negative 3/4, which means I have a rise of negative 3 and a run of 4. Remember, with negative slopes, it's only one of the parts that becomes negative. I always choose it to be my rise. So now I'm going to do my slope points. I'm going to go down 3, 1, 2, 3, over 4, 1, 2, 3, 4. Down 3, 1, 2, 3, over 4, 1, 2, 3, 4. Now I have 3 points that I can graph. I need to check and see if I have a solid or a dashed line. It's greater than or equal to, meaning it includes all the points. So this is going to be a solid line. I'm going to draw a solid line through my points. Put arrows on the end because it is a continuous line. Now I need to determine, do I shade above or below? I always test 0, 0. So when I plug 0, 0 into the inequality, 0 has to be greater than or equal to negative 3/4 times 0 plus 2. Negative 3/4 times 0 is 0, so it goes away. And my inequality is 0 is greater than or equal to 2. Is 0 greater than or equal to 2? No, it's not. 2 is a number that's greater than 0. So 0, 0 is not included in the solution. So I want to shade away from it. So I'll shade above the line. Now I need to check and see, is 3, 2 a solution? Do it my easy way. Graph 3, 2, 1, 2, 3, 1, 2. 3, 2 is in the shaded section. So yes, it's in the solution set. Or I can plug it in to the inequality and test it there. X and Y. 2 needs to be greater than or equal to negative 3/4 times 3 plus 2. Negative 3/4 times 3 is negative 9/4 plus 2. You can either use the calculator to add that together, but I also want to show you how to do it with common denominators. So to add negative 9/4 and 2 together, I need 2 to have a denominator of 4, which means multiplying top and bottom by 4. So I have the inequality 2 must be greater than or equal to negative 9/4 plus 8/4. So that I get 2 must be greater than or equal to negative 1/4. Is that true? Yes, it is, because positive numbers are always greater than negative numbers. So another way to prove that yes, 3,2 is in the solution set. Using the inequality or proving it to show my red dot, the coordinate 3,2 is in my shaded blue section. Example 3, y less than or equal to 5. If you notice there's no slope to this line. This is a zero slope, which means it's going to be a horizontal line. I still have a starting point. My starting point is the y-intercept 0, 5. I always start at whatever my y is equal to. But instead of doing a rise and a run, because there is no rise to it, it only runs left and right. Because it's a horizontal line. I need to decide if it's solid or dashed. Well, looking at my inequality, it's equal to, so it's going to include all the points, so I do a solid line. Putting my arrows, because it does extend in infinite direction, left and right. Now shading above or below, no need to test the point. I know that y less than is going to be everything below it. So I shade below my y equals 5 line. And now that's the inequality. All solutions that are less than or equal to 5. That's my point, 3,2. 3,2 lies in the shaded area, so yes. All right, number 4, x greater than negative 3. Remember back on this beginning of the notes, we talked about x equaling a number. Well, this is x greater than negative 3, which means it's going to be a vertical line, having an undefined slope. There is no y-intercept for this. What I look at is what does x equal? Well, x is always going to equal negative 3. So my starting point isn't a y-intercept, but it's the x-intercept. Negative 3, 0. It's a vertical line, so it's going to rise up and down. And it's not going to have any run to it. It will not change to the left and right. I need to determine if it's solid or dashed. The inequality says that it's going to be dashed. So I do a dashed vertical line. Putting my arrows on it because it does extend up and down and infinitely. There is no shading above or below here. This is shading to the left or the right. Well, x greater than, I want all the values greater than -3. So that means I'm going to shade to the right. So x is greater than -3. Does not include -3. It's every number beyond -3. All right, now we have a word problem. John sells hot dogs and hamburgers. He sells hot dogs for $1.50 each and hamburgers for $2 each. He hopes to earn at least $150. Identify 3 combinations of hot dogs and hamburgers that will earn John more than $150. This is the one time that you will be able to use guess and check. So take a few minutes to find 2 numbers that are going to represent hot dogs and hamburgers that will earn you more than $150. So I'll start with the easiest one. I know that hot dogs sell for $1.50 each. So if John sells 100 hot dogs, that's going to get him $150 because 100 times $1.50 is 150. If he wants to earn more than $150, all he's going to have to do is sell 1 hamburger. Because 1 hamburger is $2, 150 plus $2 is $152. One combination that earns him more than $150. A second combination. If I think about just hot dogs, or I mean just hamburgers, he sells hamburgers for $2 each. So if he sells 75 hamburgers, 75 times $2 gets him $150. And if he wants to make more than $150, that means he would only need to sell 1 hot dog. That would be an extra $1.50, totaling him $151.50, earning him more than $150. A third option, if I think about just the hot dogs, if I said he sold 20 hot dogs, $20 times $1.50 gets him $30. So now I need to figure out how many hamburgers to sell to get me more than 150. Well, 60 hamburgers $60 times $2 would be $120. All I would have to do is make it a 61. The 61 would now be $122. And I made $152. Any combination of hot dogs and hamburgers that would total more than $150. Part B says to identify 3 combinations of hot dogs and hamburgers that will earn John exactly $150. Well, we kind of already did that. So if I think about just selling hot dogs, 100 hot dogs equals 100 times $1.50, which is $150. And then I wouldn't have to sell any hamburgers at all. A second option would be just selling the hot dog, or just selling hamburgers. So just selling hamburgers, 75 hamburgers, $75 times $2 equals $150. And I wouldn't have to sell any hot dogs. So the easiest choices are 100 hot dogs and 0 hamburgers. 75 hamburgers and 0 hot dogs. And your third option, you would come up with any combination of hamburgers and hot dogs that will earn you exactly $150. An example I did, 96 hot dogs. Just using guess and check here because 96 times $1.50 is $144, meaning I need to sell $6 more, which would be 3 hot dogs, 3 hamburgers. Because 3 hamburgers would be 3 times $2, which is $6, for a total of $150. Just find combinations of hot dogs and hamburgers that will get you exactly $150. Okay, example C, same type of example, but now we're trying to find combinations of hot dogs and hamburgers that will not earn John at least $150. So once again, I'm going to go with the easiest one possible. And the easiest one would be 0 hot dogs and 0 hamburgers. If he sells 0 hot dogs and 0 hamburgers, that means he's going to make $0, and 0 is less than 150. It is not 150. It's nowhere close to $150. Second easy option would be if he sold 1 hot dog and 1 hamburger. 1 hot dog is going to get him $1.50. 1 hamburger is going to get him $2. And $1.50 plus $2 is only $3.50, which is not $150. And your third option combination would be, let's say he sold 2 hot dogs, 2 hamburgers. 2 hot dogs is going to be $1.50 times 2, which is $3. 2 hamburgers is going to be $2 times 2, which is $4. $3 plus $4 is $7, which is not at least $150. It's less than $150. Any combination of hot dogs and hamburgers that you can come up with that will be less than $150. So part D is now the algebra part of it. If you allow X to represent the number of hot dogs he sells and Y to represent the number of hamburgers he sells, write a linear inequality to represent him selling more than $150 worth of goods. So kind of like I've done in every problem, I figured out how many dogs times $1.50, how many hamburgers times $2, and then added them together. So to write the inequality, I'm going to do $1.50x to represent the hot dogs plus $2 y to represent the hamburgers. When I add those two money totals together, it needs to be more than $150, so it needs to be greater than 150. So there's my inequality. 1.50x plus 2.00y must be greater than 150.